Kyoko has $10,000 to invest. Her bank has several investment accounts to choose from, all compounding daily. Her goal is to have $15,000 by the time she finishes grad school in 6 years. To the nearest hundredth of a percent, what should her minimum annual interest rate in order to reach her goal? This is an investment problem with a compounding interest, and so we will use the amount at any time t equals the principal times the quantity 1 plus r over n raised to the power n times t. In this case, t is 6 years. The principal or the present value is $10,000. That interest is compounding daily, so n, the number of times the interest is compounding in a year, is 365. Sometimes people use 360, but we will use 365. The interest rate in the formula is not given. That is what we're looking for. What is the 15,000? The 15,000 is the amount after 6 years. And so A of 6 equals 15,000. We're going to plug in the knowns and see what is left. A of t is 15,000 equals the present or the principal is 10,000. Open the parentheses, 1 plus r, we don't know, n is 365. Close the parentheses, n is again 365 times t is 6. The only variable left in this equation is r. The goal is to isolate r. To isolate r, we will need to get to the parentheses so that we can get to r. And so we would need to get rid of the 10,000 first. This 10,000 is being multiplied to the quantity, so we would divide it. So we divide by 10,000 from both sides of the equation. 15,000 divided by 10,000 is 1.5. And on the right hand side, we left with 1 plus r over 365. And then we raise to the power 365 times 6. It is better to evaluate the exponent than to keep rewriting it in a product. And so 365 times 6 is 2190. Next, in order to get inside the parentheses, we would need to get rid of that power 2190. To get rid of 2190 in the exponent, we would need to raise the entire expression to the reciprocal of 2190, which is 1 over 2190. But if we were to do that on the right-hand side of the equal side, we need to do the same thing on the left-hand side by raising it to 1 over 2190. The law of the exponent guarantees that when we raise a power to another power, we simply multiply the two powers, and that is the reason why we multiply the reciprocal to cancel each other out. And so we can cross out these because we know that the number times its reciprocal is 1. And so we end up with 1 plus r over 365 on the right-hand side. On the left-hand side, we will keep this at 1.5 raised to 1 over 2190. We don't need to evaluate it now because we're going to use a calculator to do it anyway. Next, in order to get to r on the right-hand side, there are two terms, so we would need to get rid of 1 first. And to do that, we subtract 1 on the right and therefore subtract 1 on the left. The left-hand side is now 1.5 raised to the power 1 over 2190 minus 1. This minus 1 is not in the power but in the same line as 1.5 equals, the right hand side is now r over 365. And again, the ultimate goal is to get to r, and so we would multiply 365 to the right and therefore multiply 365 to the left. The right hand side is now simply r, and that's what we want. For the left hand side, we put all of these in a calculator. Be careful when we type the exponent and make sure we open the parentheses and close the parentheses just like this expression. Again, be careful when you use a calculator to type this in. An iPhone calculator is very bad at evaluating this expression, so make sure you use a scientific calculator or a graphing calculator. And again, make sure that 1 over 2190 is entirely in the exponent. X is out of the exponent when you type minus 1. This would give us 0.0676. And this is in percentage, so R is 6.76%. This is actually an irrational number, 0.0675837, and so on. We would need to multiply this by 100 to get 6.758377%. But the question asks us to round the answer to the nearest hundredth, and so we rounded to 6.76%.